Have you ever just stopped and wondered what makes our planet actually, well, work? It's not just one single thing. It's this incredible, complex dance between the solid ground beneath our feet, the water that covers most of our world, and the very air we breathe. Today, we're going to dive into how these major systems, these domains, all interact to create the one thing that truly makes Earth special: life itself.
I think this image just says it all, doesn't it? Our world isn't just a collection of separate parts. Land over here, water over there. No, it's a single, deeply interconnected system. And it's right here, in this precious, narrow zone where the solid ground, the vast oceans, and our atmosphere all meet and mingle. That's where the magic really happens. This is the foundation for absolutely everything. All right, so here's our game plan for today. First, we're going to lay the groundwork and define the 4 great pillars of our planet. Then, we'll take a tour across the solid Earth. After that, we'll dive deep into our amazing blue planet. And finally, we'll look up at the air that keeps us alive and see how it all comes together to create the miracle of life. Okay, so let's get started with those 4 pillars. Before we can really explore our planet, we need to be speaking the same language. So what are these fundamental components, these domains that define our entire world? First up, we have the lithosphere. Now, this is everything solid. We're talking about the huge continents, the crust of the planet itself, even the thin, vital layers of soil that give plants a place to grow. Basically, it's the ground we walk on. And its name comes from the Greek word lithos, which literally means stone. So that makes perfect sense, right? It is quite literally the rock-solid foundation of our world. Next, we've got the hydrosphere, and this is all the water. I mean, all of it. It's the massive, deep oceans, the rivers, the lakes, the giant ice caps and glaciers at the poles, the groundwater hidden beneath the surface, and even the water vapor that's floating in the air all around us. The name for this one comes from hudor, which is the Greek word for water. And then, wrapping around everything is the atmosphere. You can think of this as Earth's invisible shield. It's this protective blanket of gases that holds in heat, protects us from a lot of the sun's harmful radiation, and crucially, gives us the oxygen we need to breathe. Its name, fittingly, comes from the Greek atmos, which means vapor.
And that brings us to the 4th and maybe the most important one, the biosphere. Now, what's so cool about the biosphere is that it isn't really a totally separate domain. Instead, it's that magical meeting point, that thin, vibrant layer where the land, the water, and the air all overlap. This is a zone where the conditions are just right for life to exist. And its name, of course, comes from bios, the Greek word for life itself. Okay, now that we have our definitions down, let's really explore each one in a bit more detail. We're going to start from the ground up, with the lithosphere, and take a tour of the incredible highs and lows of our solid Earth. So the surface of the lithosphere is basically broken up into 2 main divisions. You have the huge land masses we call continents, and then you have the enormous basins that hold our oceans. And here's a little fun fact for you. If you look at a globe, you'll see that the vast majority of all the land on Earth is actually concentrated in the northern hemisphere. So just how extreme can our planet's solid surface get? Well, the highest point on land is, of course, the peak of Mount Everest. It stands at a mind-boggling 8,848 meters above sea level. And sea level is just that universal baseline we use. It's like the 0 point for measuring all elevation on Earth. But here's where it gets really wild. The lowest point is actually even more extreme. If you could dive down into the Pacific Ocean, you'd find the Mariana Trench, which hits a depth of 11,022 meters. So let that sink in for a second. The deepest part of our ocean is actually deeper than our highest mountain is tall. It's pretty incredible. This picture does a fantastic job of explaining 2 really important geographic terms. On the right, you see an isthmus. That's just a narrow strip of land that connects 2 bigger land masses. A perfect example is the Isthmus of Panama, which links North and South America. And on the left, you've got a strait, which is basically the opposite. A narrow passage of water that connects 2 bigger bodies of water, like the one separating India and Sri Lanka. All right, so we've covered the highs and lows of the solid Earth. Now let's plunge into the world of water. It's time to explore the hydrosphere, the domain that gives our planet its famous nickname. So, why do we call it the blue planet? Well, the answer is pretty simple, but it's also really profound. When you look at Earth from space, what you see is blue. And that's because over 71% of its surface is covered by water.
All the continents we live on are basically just giant islands in one massive, interconnected global ocean. But here is the great paradox of our blue planet. Even though we are swimming in water, the amount of fresh water that we can actually use is incredibly scarce. This chart shows the shocking truth. Over 97% of all the water on Earth is saltwater in the oceans. Of that tiny little sliver that's left, most of that is frozen solid in glaciers and ice caps. It leaves just a minuscule fraction available for billions of people to drink, farm, and live. Now that huge reserve of salt water is held in what we call the 5 major oceans. The Pacific, which is the biggest by far, the Atlantic, which is a super busy highway for trade, the Indian, the only one named after a country, the Southern Ocean, which swirls around Antarctica, and the chilly Arctic up at the North Pole. But the key thing to remember is they aren't separate. They all flow into one another, forming one single massive body of water.
Okay, so we've covered the ground beneath our feet and the water that covers the globe. Now, let's rise above it all and look at our final 2 domains, the air itself, the atmosphere, and that magical place where it all comes together to create the biosphere, the domain of life.
So, what are we actually breathing in right now? Well, the answer might surprise you. It's not mostly oxygen. A whopping 78% of the air is actually nitrogen, which is super important for plants. The stuff we need to live, oxygen, makes up about 21%, and everything else, gases like carbon dioxide and others, is all crammed into that tiny 1%.
And this atmospheric blanket isn't just one uniform thing. It's actually structured into 5 distinct layers, each with its own special properties. We live way down here at the bottom, in the troposphere. This is where all of our weather happens. As you go up, you pass through the stratosphere, the mesosphere, the thermosphere, and finally the exosphere, which fades into space. And the key takeaway here is that the higher you go, the thinner the air gets. The density drops off, and that is exactly why climbers on Mount Everest need to carry oxygen tanks to survive at the top.
And this brings us right back around, full circle, to the most critical domain of them all, the biosphere. Remember, it's not just a zone. It is the zone, that precious, fragile intersection where land, water, and air all meet and interact, is the only place in the entire known universe where we know life can exist, from the smallest bacteria to the largest blue whale.
And this, right here, is the single most important thing to understand. These domains are not separate. They are locked together in a delicate, intricate balance. Our actions in one domain create ripples that spread across the entire system. For example, when we cut down forests, we don't just affect the land. That leads to soil erosion, which can then pollute our rivers and oceans. When we burn fossil fuels, it's not just air pollution. Those gases warm the planet and can make the oceans more acidic. Every single action has a reaction.
So we're left with this really powerful realization. The Earth isn't just our home. It's a single, living, breathing system of interconnected parts. And the real question this leaves us with is a personal one. Knowing that everything is connected and that every choice we make creates a ripple, from the ground to the sea to the sky, what kind of ripples are we going to choose to create?